Break-even points are where you have intersections of revenue and cost functions. So it's when revenue is equal to cost, which means you neither make nor lose any money. Because if your revenue is exactly what it takes to produce something, the cost, you make no profit. So what we're going to do now is we're going to look at example 4, which is pretty long. So the first thing it tells us in example 4 is the price-demand equation and the cost function for the production of dog collars are given respectively by these two different equations. Part A, express the price P in terms of the domain X and find the domain of this function. This is the same as what we did for example 3's part A. So let's do that again. What that means is take this given price-demand equation and solve it for P. So X is equal to 6,000 minus 40P. So if I add 40P to both sides and subtract X from both sides, I end up with 40P is equal to 6,000 minus X. Divide everything by 40. And P is going to equal, well, 6,000 divided by 40 is 150. And then this is minus 1 over 40x. Then what we want to do is find the domain. Well, remember the way that the domain works for this? X is going to be trapped between 0 and whatever it takes when you make this go away. Well, the most I'm ever going to get demanded is my 6,000. So it's going to be between 0 and 6,000 in this case. Part B asks you to find the marginal cost. Well, anytime you see the word marginal, we know that what we need to do is find the derivative. So if this is my cost function, C of X is equal to 90X plus 20,000. The marginal cost, C prime of X, is going to be the derivative of this. Well, the derivative of 90X, remember, whenever X is to the first power, it's just the coefficient, so it's 90. And the derivative of $20,000, well, 20,000 is a constant, and that would be 0, so we don't need to write it. So C prime of X is 90. Part C, find the revenue function and state its domain. Well, that was just like part B of the problem from example 3. So part C, find the revenue function. Well, R of X, remember, is always going to be X times P. So in this case, R of X is going to be X times P, which is this right here. 150 minus 1 over 40x. If I distribute my x to both of those terms, I get 150x minus 1 over 40x squared. And it wants the domain. Well, the domain of this, you know, is going to match the domain that you have right over here. So it's going to be that x is trapped between 0 and 6,000. Part D, find the marginal revenue. Well, the marginal revenue just says find the derivative of the revenue function. So if this is my revenue function, and I need to find the derivative, r prime of x, well, the derivative of 150x, it's, remember, x to the first power, so it's just the coefficient, 150 minus, if I take that and multiply it, 1/40th times 2, 2 over 40 reduces to 1/20th x. Part E, find r prime of 2,000 and interpret your results. So r prime of 2,000 just says to plug in 2,000 in place of the x in your marginal revenue function. And if you do that on a calculator, you end up with 50. Well, let's interpret those results. What does that mean? That means that at a production level of 2,000 dog collars, revenue is increasing at a rate of $50. So at a production level of 2,000 dog collars, revenue is increasing at a rate of $50. Part F. Graph the cost function and the revenue function on the same coordinate axis between 0 and 6,000 and find the break-even points and indicate the regions of loss and profit. So you'll see that on my math lab where you're going to choose the graph. So let's kind of go through how you would do that. So the cost function, remember, C of X was equal to 90x plus 20,000. That's above. And R of X, remember, we found that to be 150x minus 1/40th x squared. So if we were to graph this, I know that 90x plus 20,000 is just a line. I know it's a line because it's x to the first power. So I know that, let's call this 20,000 here. So it intersects at 20,000 and it's an increasing function. So I'm just going to draw it like this. And then I know that this bottom function here, 150x minus 1/40th x squared, it's a parabola. It's a parabola that opens down because x squared is negative. So I know that it's going to go down something like this. And this doesn't have to be perfect. So this is about what this looks like. Okay, let's do the rest of this on a graphing calculator. So on our graphing calculator, I want us to hit y equals. And then in here, we're going to write the two functions, 90x plus 20,000. And for the other one, it's going to be 150x minus 1/40th x squared. And then I'm going to change the window settings so that it's more appropriate for what we have. Now remember, we're graphing this between 0 and 6,000. So between 0 and my x max is going to be 6,000. So we're trying to figure out what we should do in terms of our y's. I'm going to say my y max, let's make it 600,000. Just to estimate to see if that's a good enough window. Well, there's my cost function. And there's my profit. It looks like 600,000 is a little too much, so I'm going to cut it off a little so I can get a better idea. So let's make this, instead of 600,000, let's make it 400 and see if that's better. Let's graph it. And you might have to just play with it just to find where you can see better. See, it's still really hard to see there, so I'm going to make it even less than that. Hit my window again. Okay, hopefully 300,000 is good enough for us. That's not bad. Not perfect, but that's not bad. So it kind of looks like this. It looks like both of them are actually more over here. So my graph is actually not drawn that perfectly. So let's just kind of make it where our graph looks a little better. Because again, it looks like both of those are kind of happening if we go back to the graph here. Kind of in this section. Okay, so what we need to do now is find our break-even point and then label everything. I'm just going to erase this one last time and make it just look a little bit better. There. And I'm not really looking for anything that you guys do to be perfect. I wouldn't ask you to graph this on a test. Okay, so I need to find my break-even points. I need to figure out what is this and what is this. Well, on a calculator, what you want to do is you're looking for your points of intersection. So you are going to hit second and then trace for calculate. And you're going to calculate number 5, an intersection. So 5. And then it's asking you, okay, where are you on the first curve? So I'm going to move this down because I'm pretty high up. So I think that they're intersecting the first curve, if this is the upper intersection, about here. So this is what I'm saying, and I guess. And then my second curve, I just hit enter again because I'm guessing it's going to be about there. And enter one more time for my guess. And it shows me that I'm intersecting at the point 2,000 and 200,000. So this point here is 2,000, comma 200,000. Well, let's figure out what the other point of intersection is down there. So again, same thing here. You're going to hit second and then trace for calculate, and then the number 5 for an intersect. And I want the lower point now. So I'm going to scroll down to that lower point. And I think they're intersecting about there. Second curve, again, I'm just going to keep hitting enter with the guesses. As long as I'm close, it figures it out for me. 456,000. So this is 456,000. So for part F, it says to graph them and then find the break-even points. So my break-even points for these 2 points. And then I have to label my regions as loss or profit. Well, here my cost is above my revenue. So I know that right here this is a loss. This area here is a loss. Same thing here. My cost is above my profit, so anything over here is a loss. In this section right here, my revenue is above my cost function, so this is the only section where I have a profit. So my break-even points, again, just use a calculator for that. And then anytime that your revenue function is above your cost function is a profit. Whenever your cost function is above your revenue function, it's a loss. All right, part G. We're on G. It says find the profit function. So we need to find the profit function now. Well, profit is equal to revenue minus cost. So my profit function is equal to revenue minus cost. So P of X is going to equal my revenue function, which is that 150X minus 140X squared, minus my cost function. Well, my cost function is this 90X plus 20,000. Be really careful there. The biggest problem that people have when they're finding the profit function is they forget to put the cost function in parentheses to distribute the negative. But we're going to distribute the negative and combine like terms. So I get 150x minus 140th x squared minus 90x minus 20,000. So then my profit function, if I combine like terms and reorder, is negative 140th x squared. 150 minus 90 is going to be plus 60x minus 20,000. So that's my profit function. That's part G. Part H, so this is done, is find the marginal profit function. So the marginal profit function, so part H is P prime. So we're just taking the derivative. So you take this and you multiply. Well, negative 2 over 40 reduces to negative 1/20th, and it'd be x to 1 less. Well, 2 minus 1 is 1, so it'd be negative 1/20th x, plus the derivative of 60x is just 60. The derivative of negative 20,000 is 0, so we didn't need to write that. I, the last part of this problem, part I, is asking us to find P prime of 600 and P prime of 1500 and interpret our results. Well, how do you find this? Again, you just plug it into your marginal profit function. So it's going to be whatever negative 1/20th times 600 plus 60 is. So we end up with P prime of 600 in this case is equal to 30. So what does that mean? It means that at a production level of 600 units, our profit is increasing at a rate of $30. Well, what about P prime of 1500? Well, that would be whatever negative 1/20th times 1500 plus 60 is. And that ends up being negative 15. So what does that mean? Well, it means that at a production level of 1500 units, so at a production level of 1500 dog collars or units, our profit is decreasing. And it's decreasing because it's negative at a rate of $15. So it's decreasing at a rate of $15. That's it for section 2.7.